Okay, so we finally reached recursion, and from this video onwards, I'll be starting explaining recursion and what and how the application of recursion is, why it's important, and what can we do with recursion. Because I hope all of you who are following this series pay extra attention to what I'm going to teach from now on, because recursion is extremely important. All the things that we'll be doing further after recursion will have the application of recursion used. Even in dynamic programming, when we reach there, before that we'll be doing trees and graphs, but both of those all these three things will be taking recursion um, as bare minimum. So all the things that can be done afterwards using this will be taking the application of recursion. Alright, so let's get started. We'll be understanding what recursion is, why are we using recursion, and how it's different from iteration, meaning how is it different from what we use when we use loops. Okay, so recursion. Let's take a small example. We can take a let me explain recursion and how it's different from loops. That's what I want to do first. So let's say I make a loop. um, let's say I make I is equals to 0. Let's start with 1. I less than 6 and I plus plus. Yeah. Okay, so I'll be printing I, so print I, and that's it. So this will be printing all the integers from 1 to 5, because we stop it at 6. So it will be printing 1, then 2, 3, 4 and 5. That's what the iterations will be doing. And how it's doing is that every time we run the loop, means we'll be running the loop once, but every time the loop iterates, every time it will be taking i's value, the value that I holds at that time in the loop, and it will be printing that value, which is 1 at the first time. It will be starting with 1, and we are saying that we want to run this loop till 6. So it will be running this loop till printing 5 times, because we are not going to consider 6. It's the condition that we want the loop to stop at. So now let's say this is our main loop, and what will be our base case? What will be our base case in this entire algorithm? The base case, when we say base case, the base case basically means that at some point you need this loop to stop, right? It can't run forever. We can make loops that are running forever, we can do that, but here there is a base case. We know that the loop is going to stop once it reaches its last index, which is 5. So our base case is 6, less than 6. This is our base case. Every time we are checking whether the base case is hit or not. That's what we are doing, right? Every time we are checking if I is less than 6 or not. That's what we are doing every time. And if it is not more than 6, means if it satisfies this condition, then only it will be entering this block of code and executing the statements that we wrote in it, which is simply printing the ith iteration, which is 1, 2, 3, 4, 5. So this is our base case. Every time it's gonna check the base case. Now this is a simple loop, it iterates every time. Now let me write something different here. Let's say I'm declaring a function which takes I, int I, and let's say I is equals to we'll be declaring it as 1, the earlier condition, and here I'm simply checking that if I is greater than 6, return, simply return. We don't want to do anything else means if it's not greater than 6, if it's less than the boundaries of 6, then we simply call the same function which we named it as func. We'll be calling it as I plus 1. Simple, nothing more, nothing less, and we simply close the function. Now how is this block of code, this algorithm, different than the one where we use the loops? So here the name is, the very first thing you can notice is that we are actually creating a function. This is our function. We are taking one argument, which is I. We are declaring it as an integer. The argument is an integer, and we are checking. Very first thing we are going to do inside this loop is that we are checking whether I is less than 6 or not. Is that the case? Can you see that the same condition that we applied over here, we are checking that over here? Means it's just reversing polarity of its condition, but basically we're doing the same thing, right? Because if it is going to be greater than 6, then we are simply saying return. And in function we know that when we say return, it's not going to execute anymore. It's going to come out of the function, it's going to stop the execution, it's gonna do everything that's before the execution of function, right? So when we say return, it's gonna stop the function. So this condition, we are basically doing the same thing over here, right? So we can say that this is our base case. And then let's say this condition is satisfied, means I is not greater than 6. This condition is not satisfied, which means that I is less than 6. Then we say that we are calling the same function, but we are supposed to pass something, right? So we'll be passing I plus 1. Means what this means, let's say we are passing something here. We could be passing 1. We'll be passing 1. When we say I plus 1, that same 1 over here will be passed as 1 plus 1, because I we declared over here as 1. We are not declared, we are passing 1 as an argument in the original function. Let's say I'll be calling the same function here in the main. When we want to execute this function, I'll be passing the integer as 1. This one over here is going to be passed as 1. Here the value of I is going to be 1, and when we call that function after this base case, I am saying that we increment it by 1. So here that value will be 2, means we are incrementing it by 1 every time, and we are going to do this every time till the base case gets hit. Means now what's the actual visualization of this block of code? Because in technical sense it looks very simple, it's just saying that we are simply checking the base case, and if the base case does not get hit, you keep calling the same function with some different values. We just keep changing the values. We can increment the values like we did over here. We can do the same thing with decrement. We can even multiply. We can do anything. It's just something that's going to keep happening till the base case gets hit. That's the main thing about recursion. Now this entire block of code uses the application of recursion. Recursion basically means that to call the same thing over and over and again till we achieve our statement or our goal. And over here our statement being till I is less than 6, means I needs to be less than 6 till recursion to keep happening and again and again. Over here, let's say before I call the same function, I can also print I, right? So now what will this do? So let's say I call it as 1. When I is 1, it's gonna go inside the loop. It's gonna check that whether I is 1 is greater than 6. No, we know that that's not the case. So it's gonna print the I. So it will be printing 1. Then it's gonna call the same function with value incrementing by 1. So it's gonna call with 2 now. So for 1, this is the function, this is the print statement, So when 2 gets called, it's going to check again that if 2 is greater than 6 or not. If no, then it's going to go out of the if block, means it's not going to execute the if statement. It will be printing I, means what is I this time? It's 2. Alright. And then we are calling the same function with I plus 1. So what's I plus 1 this time? I plus 1 this time will be 3. 3 is going to go with the same thing. Whether it's gonna check that is 3 greater than 6 or not. 3 is greater than 6 or not. No, we know that 3 is not greater than 6. So what's it gonna do? It's gonna go down and it's going to print I, which is 3 this time. And then it's going to call the same function with incrementing its value again. So it will be incrementing it by 1, which is 4. This time I is 4 inside the main argument. Now this, I'll be clarifying that later. So 4 is going to be checked again with 6. It's not greater than 6. So it will call itself, before calling itself, it will be printing that value. So it will print 4. And then it will call itself again with incrementing itself with 1. So 5 this time. 5 we check again. No, we know that 5 is not greater than 6. Then it will print and 5 is not greater than 6. So it will increment it by 1, and before we do it, we print it. So it will print and then call itself with incrementing it by 1. Now here it gets interesting. Okay, so we reached till 5. We are incrementing it by 1 because we know that 5 is not greater than 6. So it will go through these two statements over here. So we say that we print 5. Yeah, that we did. Then it's going to be calling itself with incrementing by 1. So here that function means 6. This 6 is what we are passing over here. Now we know that 6 is not greater than 6 is greater than 6, means basically we are comparing whether 6 is greater than 6. Here we know that 6 is not less than 6 because we are only checking if it's less than 6. So 6 is not less than 6 because we know that algorithms do not give it as true. So here it will be false, means yeah, that's false. So we are basically checking that if I is greater than 6, meaning is 6 greater than 6? No, that is not the case, that's not that is actually, to be honest, I should be taking equal. So is 6 greater or equal to 6? Yes, we know that that's the case. So if that is the case, meaning we are hitting the base case, right? Because we know that we have to stop the main recursive means this function at least once. We need to do that. So we are checking that is 6 greater than 6 or equal to 6. Here here we are saying that it is equal to 6, right? So it's going to go inside this if block, and inside the if block we are saying that we return it. Now here it gets interesting because 6, we know that 6 is not gonna get executed with these two lines, with 6 as the value. So we say that it's false. We say that we have to return from here. Now when we say return, like I said, we said that when we say return, it's going to come out the function. The function is going to stop executing. All the things that we reached over here will be the last things till the return statement, right? So 6 won't be printed because we are not even reaching that print statement. And if you are not reaching that print statement, meaning all the things that come after that won't be executed at all. So we are basically stopping the loop, and that is our base case. This is what basically recursion means. So I'll not get much into the technicals of what recursion actually looks like inside the memory, but if we want to get into a little bit of it, I'll be saying that recursion basically uses a stack memory. So when we say that we are reaching over here 1 as the argument, it's saying print 1. So 1 gets executed in the the stack. It gets printed, then it gets popped out. The stack is empty again. we are saying that it reaches 2. 2 gets inside the stack memory, it gets printed, and it gets popped out. We'll be talking about stack later on because it is actually a data structure. Same thing goes with 3, 4, 5, and it won't actually take 6 into consideration because we are not putting 6 into the stack memory because it's not satisfying the base means it is satisfying the base condition. That's why it's not reaching further on to go to the recursive call. So all the things that are going to be considered inside the recursion will be going to the stack, will be going inside the stack at least once. I want to definitely explain this entire concept of recursion, all the programs, all the codes, all the algorithms that we'll be using for recursion using some actual code. So that's why I'm definitely going to the algorithms, means my VS code after this, because I know it's going to get tricky if I don't actually code and show you what's happening over here. So we'll be using the same functions, this same block of code over here, this same block of code I'll be writing inside my Java, and we'll be seeing what's actually happening, right? So let me write that, and I'll show you what's actually happening. Alright, so here's my Java, and let's write a public PSVM, and let me declare a function. So static void, yeah, I'll be saying int actually. I should be, let's do void, we'll do func, static void func. It's taking something as an integer as its argument, and we'll be taking so alright, so very first thing we'll be doing is checking the base condition, right? We want to check the base condition whether it's hitting that or not. So for that we'll be simply taking if I is greater than 6 or not. That's what we are checking, right? So if that is the case, then we simply return, and we don't want to go further. Alright, so now that's completed, we'll be going down there, and the very first thing we want to do is simply print the I. That's what we'll be doing, and then we call the same thing func, and we give it the argument, which is I, but we want to increment it by 1. That's what we are doing, right? In the same example I used 1. Alright, so here I'll be simply calling the same function. I'll be calling func, and I'll be giving it the value of 1. Alright, simple. So I did not I did not want to make the function return something, so that's why I simply used void. We'll be taking other examples where I actually return something, because it's going to be useful and it's going to clear your concepts even more. So for this one I'll be simply taking void because it's not going to return anything, and we are incrementing it by every time by 1, and yeah, let's see what this actually does. Alright, so I'll be compiling the code, recursion and Java. Okay, see, oh okay, so yeah, over here I should be taking equals actually, because that's what we did, right? Is greater or equal. Alright, so let's do the same thing. Okay, see, 1 2 3 4 5. Alright, that's what we discussed was actually happening in the actual program, right? Oh, okay, here it's printing 1, then it's printing 2 3 4 and 5, right? That's what it was doing. Now to actually understand what recursion can do, let me simply change one sequence of formula, one sequence, and you will see the magic that how recursion is actually working. I'll be simply taking this print statement, and I'll be putting it after we call the function. Now we know that every code in algorithm, every line in code in our function has a sequence. Now simply change the sequence. I just did a simple thing. I called the function first and then I'll be printing it. I hope that does not change anything. I hope that does not change much inside my code, right? Recursion of Java, right? And I'll be calling the function. I'll be calling my recursion. Okay. Oh, now it's giving me 5 4 3 2 1. Earlier it was giving me 1 2 3 4 5. Now it's giving me descending. How is that happening? Yeah, I just simply took system.out.println after the print statement. I simply took the print statement after I call the function. Why is it changing my entire order of how I want the elements to be printed? What's happening right now? Let's see to the whiteboard. Let's discuss this. What's happening actually? So here, print and then call, right? I'll be taking a clear space. What I want to do actually is call the function first, I plus 1, and then print I. I simply change the sequence. Now when I do this, what's actually happening? When I say I plus 1, and here let's call the function so it gets clearer as to what we are doing. So when I say I call the func1 with value as 1, I'm saying that you go inside the function, you check whether this 1, that the argument that we are giving, is it less than 6 or not? Is it greater than 6 or not? So it's not greater than 6. Then it will be going down and executing these two statements. These two statements, the first thing now we are changing is that we are calling the same function over again, right? So what's actually happening? This function, we are now, before we are printing it, we are calling it, right? So here only we are going down there and we are calling I plus 1, so it gets called as 2, right? We are not printing still, we are not printing it. So what's happening inside the stack memory is that the returning means before we print it, we are storing the value of what we want to print. Means this func1 is going to give us the value of 1 when we print it, right? Because that's what we are saying after the function, after the function calling statement, we are saying that we print that value. So before we print that, before we even reach that print statement, we are calling the recursion. So it needs to store that value, right? So it's storing that in the stack memory like we discussed above. Okay, now it's not going to print that again. Let me clear that up. It's not going to print that. It's going to call itself again with the value of 2 this time, and it's going to check that 2 is greater than 6. It's not, so it's going to go over these two statements again. It's going to call itself again with 3, but before it does that, it will be storing that return value, because we know that it's going to print something, right? We know that we are calling it to print 2. So before it prints, goes to the next function call, which is for 3, it's going to store that into the stack. Alright, so it's now 3. It's going to check that 3 is greater than 6 or not. It's not, so it's going to call itself again with 4 this time. But before it calls itself as 4, it's going to store that 3 inside the stack, because we are saying that we want to print it. Means we are going to do something with those values, right? That's why it's storing that into the stack. Alright, so it gets called to the 4. Similarly, it will be going for 5, but before it goes to 5, it will be storing 4 over here. Same goes for 6. Same thing, like we checked for the 6. 6 is not greater or equal. 6 is greater or equal to 6. So it's not going to execute these two statements. So we simply say return. If you remember over here, we are saying that we are returning. Now, what does this return mean actually? Is before it goes to 6, it will be storing 5, by the way. So when we say return, it's going to empty the stack. Now what's in the very first thing of the stack? 5, because that's the last thing, that's the last function call that we stored inside the stack, right? And that function call's value is going to be printed out first. So once it gets printed out as 5 first, the stack would be looking something like let me make a better one. 1 2 3 4. Alright, so it will be looking something like this, and it's going to pop out 4, and it will be printing that. So 4 gets popped out, and when it gets popped out, it will be executing that call, that function call, which is printing that value. Now it's going to go with 3. It's going to pop out, and it will be executing that function call, which is print 3. So it's going to print 3, then 2, then 1. All the values will be popped out one by one, and when they get popped out, their actual function calls will be getting executed. Means whatever is after this recursion call, all the things that we want to do will be executed after it. Meaning, simply this statement over here, print I, that is the statement that is after the function recursive call, right? So all those statements for each will be printed, will be executed, not printed because we are printing in this case, but it could be something like complex calculations, right? So it will be doing that. Basically what I'm saying is all the values will be getting stored. These are not values, by the way. I'm clearing that again. It looks like it's values, but it's not. These are actually the function calls. These are function calls for 5, 4, 3, 2, 1, because we started with 1. That's what is happening, and that is why it's executing out 5 first. It's printing 5 first because it stored the 5 as last. All the values will be getting popped one by one after each other inside the stack memory, and when it gets popped out, it will be executing that values function call, which is this print statement. This is the print statement. Let's say there are 3 or 4 lines after this print statement, which are maybe saying that also print I into something, maybe 5, I into 2, I into 3, I square something. All those things will be printed for 5, then all those things will be printed for 4, and then all same will be going for 3, 2 and 1 till it reaches 1, till it empties its stack entirely. All those things will be happening. So we saw this same thing, right, inside our VS Code. Let me prove my point that it's going to be printing all the other things for each function call. So let's say I also do SOT I into 2. So it will be, now what's going to happen, I hope you can understand the logic of where I'm going through with this. So it will be printing each values print statement, which is 5 and 4 and 3, and along with that it will be also printing its double. Means for 5 it will be printing 5 and 10, for 4 it will be printing 4 and 8, for 3 it will be 3 and 6, 2 and 4, 1 and 2, right? That's what I'm going here over. So let's execute this and it will be clearer. Java C recursion, Java recursion. See, for 5 it's printing 5 and 10, for 4 it's printing 4 and 8, for 3 it's printing 3 and 6, for 2 it's printing 2 and 4, and for 1 it's printing 1 and 2. That's what I was trying to explain over there. Meaning, when it gets stored inside the stack memory as a function call, it gets stored as that function call. It's not the value that we are storing inside the stack, it's the function call for that value. Means for 5 we are storing the function call for 5 over here. This 5 is not a value, it's a function call for 5. When it gets popped out, it gets popped out as its function call for 5 as the value. Means all the things that are after this recursion over here, after recursion statement, all the operations, I'll be using the word operations, will be executed for that function call, and that function call which is stored inside the stack every time, which were not. Now it is storing inside the stack because it's getting used in such a way. In previous example, means in the ascending order, it was not storing all the values inside the stack one by one. It was simply storing in one after one, and before it stores the other one, it was getting popped out as one and it was executing. For this one, it was storing one inside the stack, and it was instantly popping out its function call, which was simply printing 1. So the stack was getting empty. For the second one, it was storing second, and then it was popping out that function call for second, it was printing 2, and then the stack was getting empty. For the third one, it was storing 3, and for all of that, that was happening in that case because we used the print statement and the recursion call in that way. You have to understand the application and the logic of what and how, where the recursive statement should be used. This simple, ascending and descending logic sort order I just explained covers entire almost a large portion of how recursion is getting used. This is where the most of the things can be confusing. I hope if you maybe you can watch other videos and all, try it out yourself, all those things. But this is where the recursion hits the most. In the other videos we'll be directly going with some other complex algorithms, because if you remember that I was saving that quick sort and merge sort for recursion, because we can't do that without recursion. So it's very important that you understand the application of recursion. That's what's important over here. Alright, so in the next few videos we'll be completely discussing about recursion only. We'll be solving some codes, complex codes. It will be slow at first. We'll be taking step by step, and then we'll be getting to complex codes. So I hope you understood a lot through this video. Like, share and subscribe. Comment if you have any doubts. I'll be happy to clear them out. Yeah, so in the next few videos we'll be talking about other recursion codes and all. Thank you.